So today's webinar is focused is the first of a series we've put together to highlight the role of inspections in energy code compliance. So this is going to be more of that higher level overview, and over the next couple of weeks, this is going to be part of a series that kind of dives deeper into the specific components that we'll kind of do an overview of today. So again, this is inspections, and it's really intended to kind of reinforce some of the things we've talked about up to this point. For those of you that might be interested, I have thrown into the chat the slides we'll be using today. So feel free to download those now, or you can wait and get the email later. So let's go ahead and get started. For anybody that might be new and doesn't know, we're always getting new people. I think it's always a great idea. Make sure that if you want, you can always share the link with those that may not be participating. Again, we're always trying to get more involved with our builders and local designers so that we can make sure that we have this conversation as a whole holistic community. But my name is Josh, and I'm with the Minnesota Energy Code Support Program. And the purpose and mission of that team and that project is really to support, empower, and educate building professionals throughout the entire state on what it means to be energy efficient with the current code. We have some, for those of you that, again, you might already be aware, but we do have a website. Hopefully, that's probably how most of you found us in the first place. And so on that website, there are some specific things that are useful, helpful, we think, for you. And we always try to make sure that we try to keep that updated as best we can. Realistically, if I can get my laser work. Anyhow, my laser is not happy with me. There it is. And so one of those resources that we find on there that I really is going to be kind of a little bit of a launching pad for much of our conversation as we look at the inspection series. I know next week we're hoping to unveil and unleash our plan review checklist, but on our website now under the technical documents is our series of technical inspection guides, resource guides. Again, if you go to our website on the technical documents, you'll see it listed as a series of different guides associated with different components of the energy code compliance packet. But basically what we've provided is maybe a series of checklists of different things specific to maybe insulation versus, and so give some little reminders of what it means and what the different components are and what to look for, code references and those kinds of things. One of the things we're trying to do, I've got a meeting scheduled for next week, is also to create this in a pocket-sized version that we could provide to you at some of our in-person trainings as a way to, again, assist you in making sure that both, whether that's for you, your staff, or your inspectors, or for your contractors. Again, I think this is a resource that will be helpful so everyone's on the same page moving forward. Now, if you have suggestions, comments, or criticisms to the project, please always feel free to reach out to us. We all know that the only way, sometimes the best way to learn is through trial and error and good conversation, right? It's like code development. It takes more than one, right? But when we think about the concept today, when we start talking about this idea of inspections, I think one of the fundamental things that we have to recognize is that even as inspectors, and throughout the entire process, we all need to understand the why if we're ever going to figure out the how we accomplish some things. And why we have building codes is because we're trying to provide a basic uniform performance standards for structures built across the state, right? We don't want things in Duluth to be different fundamentally from things, let's say, in International Falls or from Monticello or Maple Grove down to Rochester, right? We want to make sure that buildings follow a series or a sense of consistency. I had a contractor recently ask me, why don't we just do, I was okay with the 2003 code. Why do we need to change it? Well, the reality is part of that process, as those of you that are participating in the tag development process for the state, part of that reality is that there are new technologies, right? There are different components and understanding when it comes to how systems operate and work collaboratively, and that's why it's always a learning process. And I think that some of the best experiences that and more experienced inspectors are those that take that seriously, the responsibility to educate and to learn new ways and to learn from others. It's not just a series of this is how I've always done it and that's how you should do it, right? We'll talk about that as we go through this presentation. But it's understanding that we're looking for some basic uniform understanding of how buildings are built. And I don't know why hopefully my hopefully I'm coming through okay. My computer's acting a little slow, so hopefully it's not a problem for you. If for some reason you can't hear me, make sure you use the chat. Tell me you can't hear me, you can't understand me. I'm sorry I talk too fast. I'll try to do my best to do that, to restrict, to regulate that. But again, if you have any questions, make sure you use the chat, use the Q&A, raise your hand if you want to jump in with a verbal comment. When we look at what the energy code, the purpose behind the commercial energy code, what we're looking for is how do we build a building with a mindset towards governing and controlling. It's all about control, right? Whether that's the building code or the energy code, it's all about control. And so we're looking to control heat loss and climate control, as well as deal with illumination and light, natural ventilation, those type, light and ventilation, those types of things. And so when we talk about energy code compliance, we know that energy code compliance really begins on paper, right? It begins with a set of construction details that give us all the things that we need to know about how this project is going to work. This is the relationship between building inspectors and plans examiners, right? And this is why I've used this example before when I ran my department. We brought the two together. We made sure that we had staff meeting as a whole, even in when I worked for the large jurisdiction with hundreds of employees. Every once in a while, we would get together to make sure that we had this consistent conversation of what am I doing in the field and how is that being supported in the office, and vice versa. What are we missing in the plan review that would better serve the inspectors in the field, right? To make sure that conversation is a two-way street. And part of what we see in the energy code is a series of 18 different specified items that should be part of that construction detail. Now, we talked about plan review last week, and that's a different series. But we'll see here the dovetail between the two. And then that's really, while we say that energy code starts on paper, energy code compliance requires inspections, right? There is no way that I, as a plans examiner sitting in my office, am able to use my binoculars and see every project, right? And to the best of its ability, virtual inspections hasn't gone that far, right? And so we need people in the field actually verifying the installation of our building components and that they're being properly installed. And again, that's not just something specific to energy code, right? This is part of that basic understanding of all buildings that there are certain required inspections that the building official should make as part of enforcing the code, right? We don't just say here, yep, you got a great plan, go do it, have fun, right? No, we have the inspection process for a reason, and that inspection process incorporates a variety of different things, right? We see here the list from the Minnesota Building Code listing some of those required inspections. And what we see, and again, not that the energy efficiency inspection has to be an independent, always independent step out verification. We can start to see places where maybe we can integrate the two, right? And we'll talk a little bit about that as we go through this series, that there are places, natural places where maybe doing a footer inspection or a foundation inspection is a time to do an energy inspection, right? If we're installing a foundation and that design incorporates that rigid insulation along that footer or that foundation wall, do both, right? We don't have to call a special inspector just to do the insulation. Same thing we do rough inspections, right? We're doing a rough-in inspection. We're doing some of those framing inspections. We can see, is there, in that design, does it call for certain components, and are they properly installed? And so that's part of what we'll talk about throughout this conversation together. As an energy code, the energy code has certain expectations associated with the types of materials and the level of installation that should be involved. The code breaks it into chapters, chapters 5 for thermal offloading, 6 for the mechanical system, 7 for the service water, 8 and 9 for power and lighting. But then within those chapters, the code also breaks it out to the mandatory, prescriptive, and alternative compliance paths. So again, what we see in energy code is an understanding and a recognition that energy code compliance paths are important. And as an inspector, they're important as well. Right? This isn't just something that we do at the front end of the process and then move on and say, okay, we're done. We don't have to worry about it again. It's important. It's fundamentally, at least in my opinion, I was told earlier I probably have drank the Kool-Aid. I at least got this. I didn't drink the whole jug, right? I'm not the Kool-Aid man, although I do have the similar hairstyle, right? That's a reference for the older crowd in the group, or the anyhow. But what we do see as an inspector, it's important I understand, right? When is the project following the prescriptive expectations of the code? When is it the letter of the code, and this is the method of installation? This is what I'm expecting. And versus when we're using more of one of those alternatives, right? When I'm starting to see an energy cost calculation, when I'm seeing a performance design that incorporates different methods or levels of insulation, for example, right? If I know that I need an R20 in the wall, and I go to that wall and it's got an R15, then I need to know, is this a prescriptive project where that is not correct, or is this a energy rating or a performance rating system compliance path where that might be appropriate given some other components and characteristics that I need to be aware of, right? And so really it starts to turn into a conversation of, do you know what am I supposed to be looking for, and what level of expectation am I supposed to have? Again, if I know I'm supposed to have an R20 in the wall and I see an R30, do I immediately say, oh, we're good? It's got an R21 sticker, we're good. When in reality, that design calls for an R30 because we're using a different mathematical calculation for energy cost, right? And so again, that's part of this process of understanding how these compliance paths impact the inspector in the field as well as the contractor. Right? It's part of that education process that we as building officials all get to participate in, right? My wife makes fun of me. She said, "Didn't realize you wanted to become a teacher, did you, when you started in the inspections?" No, but in our reality, that's kind of what we are, right? We are as inspectors, we don't just bring the hammer, right? We sometimes use the kid gloves and say, look, this is how this needs to be done to get it effectively installed. Moving on. So when we start talking about inspecting for energy code compliance, again, we're looking at these. I tend to bring it up as these four specific are these 4 pillars of energy code compliance. And based on our understanding of the inspection, the information that's identified in the energy code, we can expect what we're going to inspect, right? There are certain components that we've been told either in chapter 4, as we saw earlier, that need to be provided. And then as we go through the inspection, as we go through each of those chapters, it again reinforces some of those inspection expectations. And so we're looking for things like insulation, fenestration, mechanical equipment, right? We know, we've talked about in the past, and as we get into deeper conversations regarding some of these types of components, there is no energy specifically used in the daily operation of insulation, right? My window doesn't have a power cord. My wall does not have a fuel burning furnace powering the insulation, right? Those are systems that work together to help the mechanical components properly operate, right? To effectively and efficiently utilize their energy sources to provide their expected purpose, which is going to probably be heating and cooling. And especially this time of year, it's time for the heating, right? And so if I have, as we'll see and we'll talk about throughout this process over the series, when we talk about inspections, we're really talking about how do they all work together, and to just do the mechanical inspection and ignore the building thermal envelope would really be ineffective, right? It doesn't matter how effective. I can have a 99% efficient furnace, and if I have a hole in the wall, it's still going to lose. It's still going to have uncontrolled heat loss. Now, there's a level of controlled heat loss that we know is going to probably exist just because we can't, put an R100 in the wall. But again, what we are looking for is that controlled level of exfiltration or a controlled level of heat loss. The same way when we talk about mechanical systems, we talk about, a known air infiltration rate. Like we know the building's going to bring in air, how much air, and do we know how much it's going to be, right? So we can control and calculate those values. Anyhow, digression, we'll keep going. So we talk about insulation and the building thermal inspections associated with quick. Let me see. Can you hear me? I can hear myself. So when we start talking about insulation and the inspections associated with that building thermal envelope, we really start to look at what are the expectations regarding certain types of features, right? One of the fundamental things, and we think about it, and we'll get deeper into these when we get throughout the course of the series. One of those fundamental expectations is understanding where. Chat is disabled. Let me double check. Okay. Thank you, everybody. I've re-enabled the chat, and I'm glad that you can hear me. So let me just answer and close those so that I appreciate that. So again, I'll throw this in there just real quick while we're still, I know we've had some people join in. And so again, for those that might want them, there are the slides that we're looking at today. So when we start talking about that expectation of the building thermal envelope, it's fundamental that we understand what it is, right? If we start thinking about where it's at, what am I looking for? Am I looking for, we know that there is an exterior wall that separates the environment from the interior spaces, but now I need to start thinking about what is my conditioned space within that design, right? If we're looking at this particular example we've used before of a convenience store, if this is the drawing that we're provided, then we see that we have a level of thermal control within this space, and we see this receiving area, right? We could call it for lack of a better term, a vestibule or a docking area, right? We see this as thermally isolated from the rest of the space, and so that's telling me that we're not conditioning, or that we're considering the conditioning of this differently than we're conditioning this space, right? I also need to see it from an elevation perspective, right? Am I doing the entire building, or is there some threshold to which we're going to talk about later that might be important to understand? So understanding and clearly identifying the scope of my thermal envelope is important, right? Because it's going to tell me what I'm expecting. Now, if this continued to cross, and we incorporated this space into our thermal envelope, right, then we would not need to necessarily, depending on what's going on, thermally isolate these walls individually, right? So we can have some flexibility. It really becomes a question of what are we trying to control, right? Are we controlling the entire building, or are we keeping this area separate because we don't want to worry about how often that door is open, right? And this door we might be open, but that door is not going to be open, right? We don't want to, so there are going to be times when we start to calculate and consider how is this building going to operate effectively. Within that, we understand there's, again, the code identifies specific concepts like building envelopes and exterior versus semi-exterior, right? When we're enclosing semi-heated spaces versus unconditioned or conditioned spaces. And within that system, we know not only where it is, but kind of what it is, right? And so we're looking at these types of assemblies as part of that process, right? Whether that's roofs and with horizontal systems like roofs and floors versus vertical systems like walls, right? And so and fenestration. And so how do these systems all work together to properly isolate and control what is the scope of my conditioned space? And as an inspector, I want to know where am I looking, what am I looking at, and more importantly, what am I looking for, right? And that's when we get into this concept of the building, the R values and U factors associated with the insulation. Insulation is the primary vehicle for thermal resistance. And so we use that as kind of our first linchpin in this conversation. But we know that there are a variety of different types of insulation that could be available to a design. And so we're starting to see so we'll see through this process what are the different ways we evaluate those insulation materials, right? The code gives us some options, and one is going to be our prescriptive, again, compliance path. Again, I need to know, is this the table that we're using if I'm doing my inspection? Again, do I know that if I'm looking for an R, a wood frame wall, I'm looking for, I'm going to zoom in, I'm looking for that R19, right, with a 5 continuous. But when I show up, I see that they don't have any continuous insulation. So what am I doing, right? If I'm following that prescriptive compliance path, I'm looking for the table, the values that are found in the table. Again, that's in the R value. Now remember, this is the minimum R value for a particular component or assembly, right? And those R values are reflective of the amount of heat that transfers through that material, right? And so as we get higher numbers, that means less heat is passing through. It has greater resistance, the R resistance to the heat loss, right? Heat transfer through that system. And then the alternative to our R value is going to be our U factor, right? So we're given a couple different options, and even in that innovative, flexible this way we view energy code compliance. And so we have the R value, which is the individual material. We have the U factor, which is the total evaluation of the assembly, right? So we start to include insulating boards. We start to include sheathing and exterior cladding, interior cladding, or interior coverings, right? We look at the entire assembly and then calculate all those components together, multiply them by their potential framing factors, how much of that wall is wood versus cavity, right? Depending on designs. And we come to what is going to be ultimately a U value, right? This is going to be that amount. This is going to be the value that drives how much heat loss goes through the assembly as a whole, right? Weighting all the components that exist. So in this design we see here, we've got an R13 in the wall and an R3.5 in the wall, in the continuous insulation board. 13 in the cavity, 3.5 in the continuous insulation. That gives us a U factor of 0.057, right? This value, this design, and we're looking at a wood frame wall in this particular design. Our maximum U factor is 0.051. We exceed it. So we cannot comply with the U factor calculation. Our R13 plus 3.5 continuous is less than the 7.5 continuous identified in the minimum expectations of R value compliance. So again, does not comply, right? Neither one of those alternatives comply. Those calculations would comply. And so then we start to see where we can start to move and flex that cavity, right? Let's say I want to keep the 3.5 continuous because that's what I've got, but I want to add a little bit more to the cavity. If I go from a 13 to a 17, which is still less than the R19 that we saw identified, then my R value would be 0.048, which would be less than. All these different options are less than. So then again, that's when we would be in compliance. So by putting in a 17 with my 3.5, I could be compliant with the U factor calculation. So the question that we have here is, how did we get to 20% wall framing? So that goes back to you could get the framing factors based on your design, right? So this would be a 16 on center. If you go to maybe to a I think it's 24 on centered, it's going to be 18%. So it's a mathematical calculation. If we look at the entire wall assembly, right, what is the percentage of that wall that is cavity versus continuous is what we're looking, or cavity versus framing. So that's the framing factor. You can get that value from both the designer. You can get that framing factor. Typically, it's just a framing factor from a design, right? If we're gonna have this layout of wall, 18 on 16 on center, then that's what we're gonna have. That would change depending on, again, the wall design, right? So if we were using, let's say, a steel frame construction, right, where we have a larger or wider capable or spacing that's available to us, then again, that's going to change that framing factor. So the framing factor is unique to the wall. That's the area of the wall that's going to be that is wood, right? Hopefully that made sense. So when you look at the math, I don't know if you can see it real well. So I've averaged, I've added all together all the R values of all the components at the insulation, at the cavity. And now I've determined that in this particular wall, 80% of the wall is cavity, right? Not, and that, so I've excluded the windows areas. I've excluded, I've excluded all that. And then 20% of that remaining area is going to be the framing, which is this value here, where instead of using the 13 batt, I'm taking the R value of the wood, the 2x4 turn to where I have 4 inches of yellow pine or something, right? You can get the density of that wood relates to its thermal resistance, right? The R value. The U.S. Department of Forestry provides a book of wood, which tells you every type of wood that's manufactured and utilized, and its R value. You can actually go in and check it. I usually keep with me a little pocket reference, and in this pocket reference, I've got a paper clip. It actually has, you can't see it, my bad. But in my pocket reference, it even has the R values of different woods, right? If I was looking at, let's see, hardwood versus softwood versus plywood. So each one of those different materials has its own particular R value. Those are calculated through the testing methods identified in the standards. Hopefully that answered that question. But again, that value is something that you're going to have specific to this wall design, incorporating the amount of windows, the amount of wall, the amount of cavity. So yeah, so we can have some variety, right? So this is why it's important to understand what's my compliance path, what's my expectation, and if plan review is got, and again, when plan review is done properly, and we have these values identified on my construction details, it makes it even that much easier. I know that I'm looking for an R17 with 3.5 continuous. It's not my memory saying, "Oh no, you have to have an R19." Nope, I don't have to have an R19 because I'm using the U factor calculation at a 0.48, right? Make sure knowing these things are important for me as an inspector, right? Part of what we also know is, so we have the prescriptive compliance, then we have the building trade-off compliance. That's when we're seeing something like a ComCheck or some other report that's done the math associated with this calculation. And so again, that document is going to tell me, what am I expecting at the cavity? What am I expecting in continuous? And then that's going to also drive the conversation when it comes to what's supposed to be installed in the field. Now I'm going to say it again. I've said it before. I've very rarely been on a job site where the contractor's walking around with a ComCheck in their hand. That's why as plans examiners, I encourage us to make sure that it's not just the ComCheck, but that those values are written on the construction details, right? Because we want to make sure that it's as everywhere as possible, so that when we get on site, we're not saying, well, where's your ComCheck? I don't know. Well, it's not on your plan, so I need the ComCheck. Well, I don't know where the ComCheck is, right? So again, making sure that we have all those details on the construction documents that are provided at the site. But again, this trade-off is looking at how does that overall thermal envelope, where can I trade off? Can I get less insulation in the wall if I have more windows, or better windows, or less windows means I can get away with certain things. So again, that's the mathematical calculation determined through this system, through a series of systems. And we'll talk more about some of those different systems as we go through. Part of the expectation is always going to be, and we'll talk more about this as we go through it, labeling and proper installation, following the manufacturer's installation instructions. And so again, as a contractor, as an inspector, I need to know, what are those expectations? Am I looking for labeling on certain types of materials, or am I looking for a report that says what was installed? Because if I don't know what to expect, then it's going to cause more problems. I cannot look at this bat and tell you just by visual acuity what this is. I need somebody to mark it. What did you install, right? And not that I don't say I'm not suggesting contractors are nefarious, but I also can't utilize, hey, there's some trash over here that says this is an R21. No, I want to see it. I want to see it on the document, on the piece of equipment. I want to see that R19. And then if this person lied to me, guess what? They committed the infraction, right? I don't like lying on government forms, right? That's why I like other people. If somebody's gonna get in trouble for lying, it's gonna be this guy, right? Not me. And so there's also installation instructions, and we'll talk about these again in greater detail as we go through. But again, if we're looking at whether we're looking at loose fill insulation or something that requires baffling, what are we expecting to accomplish? We want that baffle to be properly installed so that air flows through the design and doesn't affect the installation of maybe some loose filled fiberglass or cellulose or some type of loose fill right here. We'll show some examples in our next when we talk about installation of some of these issues that we've seen. And again, we have ratings associated with substantial contact and recessed equipment, installation of protections for our insulation. Right, we want to make sure that the insulation doesn't become deteriorated through just standard preventable damage, either by just maintenance equipment or by other things like landscaping, sunlight, those kinds of things. Again, I can say as a bad child in my youth, I didn't quite understand what the plastic the plastic outside of my wall was at my house, and so I thought it was cool to watch it burn. Right, I was a little bit of a pyro. Not that I got in trouble for it, but I got in trouble by mom. Right, when she found me out there burning the water barrier. And so again, we want to make sure that we protect this as best as possible. Now, we can't stop all stupid, exact right. You can't stop stupid like me, but we can do what we can to prevent it from just expected damage. And as an inspector, we would want to know that. When we talk about the extent of maybe of roof insulation, this is an example of where the code tells us that they have to be staggered, but the code doesn't get into the level of how do they get staggered, right? I've been in trainings where people have said, well, it's whatever I say it is. That's what's going to be, that's what staggered means. And if I think it needs to be 2 feet, it needs to be 2 feet. If I think it needs to be 4 feet, it needs to be 4 feet. Well, what does the manufacturer's installation say, right? How was it tested to perform? And that's usually a better way to say, what is the expected staggering of, let's say, this particular design of rigid insulation, right? The same thing happens when we talk about house wrap, right? If it's 9-inch, there are certain designs that say if it's 9 inches overlapped, then that works for a water resistant barrier. If it's 12 inches, now it's going to be a air barrier, right? And it's going to be sealed. So again, what does the manufacturer say for its installation? Trust me, the manufacturers want their product used, and so we want to make sure that that's designed, that we understand what are those installation expectations. And again, this is one of those realities we'll talk about again, that where we may be using technology to assist us, but make sure that that technology works. Using a drone to do an inspection on the roof system, we want to make sure that we can actually visualize these staggering expectations, right? Are we sealing each layer of this stagger? I don't know. I need to know what's expected from the manufacturer and what's being done. So, but like we said earlier, insulation is not the only component in that building thermal envelope. They also includes the concept of fenestration. We know the code identifies for us a variety of different expectations on the U factor, right? Because we're looking at the assembly as a window, right? The framing, the glass, everything involved. And so in the space, the air spaces or gases that exist in between those paints. And so that's how we calculate these U factors. And what are those maximum U factors we're going to allow in different types of fenestration, whether that's doors or windows or skylights, right? And so when we start to evaluate those things, that's where it's important for the building inspector to understand. It was designed to have this level of a U factor, and that U factor impacts how much heat is lost through that assembly or moves through that assembly. Heat loss, heat gain, right? Depending on the season. We're talking heat loss right now because it's so cold out. But if that window is not doesn't have the appropriate U factor, then we're going to lose more heat through it, and that could affect how well our equipment works. We've based our equipment design on a certain level of air infill and exfiltration, and if the windows don't match with what we've designed, then our entire mechanical design is going to be off, right? It won't work the way we've designed it. Same thing with solar heat gain. Solar heat gain is the amount of solar radiation impact on the temperature of an interior space, right? So are we allowing uh, how much are we allowing the solar radiation to impact the interior design, the interior latent temperatures, right? And so again, those are things that we need to know. Now, I've had people ask if, okay, so if I go out and I do this inspection and I'm looking at a window and let's say in this projection, this projected wall system, these 4 rows are supposed to be an a U.3, and these are supposed to be a U.2, and they've got them reversed. Would you make them replace them? Absolutely. You did it wrong, right? If they put the wrong door in, am I going to say it's okay? It's okay if it doesn't match the plans. No, I'm going to make them do what I know needs to be done, and that's where it's important when we start looking at designs. This is the one thing that when I worked with when my plans examiners and my inspectors got together, when they would get together, this was the biggest issue we always had was proper identification of window values, right? We get, okay, this window has to be this size. But if that plan detail does not say what level of air leakage and solar heat gain is supposed to be there, that makes it very difficult for me. I know the size of window is different. And that's where it really became a conversation that over time, our plans examiners expected out of our contractors and our designers. We want each of these windows, if we're going to have different window types and different elevations, specify on the details. What are those expectations for air leakage? What are those air leakage, U factors, and solar heat gains, right? Because that way they can be effective in their job as inspectors, right? They're not saying, oh, I know you're supposed to put a window here, so as long as it fits in the hole. No, I want to know what the air leakage is because our inspectors took seriously their role as protectors of the public. And so they want to make sure that it's not overheating in certain areas and impacting how this equipment is going to operate. So again, the code provides us a variety of different expectations and minimum and maximum air leakage rates associated with these designs. And so again, if those specifications are on the detail, then our inspectors can do their job and make sure, right? Our plans examiners don't have to put their binoculars on. They've given the work to the inspector, and the inspector will accomplish it. Now, understanding that air leakage reinforces that air barriers aren't an afterthought, right? They can't be an afterthought. The code identifies them as one of those details that needs to be included as far as air sealing, because the code recognizes that air movement has consequences, right? It not only affects the thermal resistance, but it also affects things like vapor and water transfer or pollutants, smog, smoke, exhaust, right, that move in and out. When you think about what's going on out in California right now, if there are fires, then poor air movement control, poor air leakage control means the infiltration of smoke into the neighborhoods. If people have allergens, and again, they're allergic to certain types of things, and they aren't able to control their thermal envelope the way they thought they were controlling it, then it can impact their health, right? I remember several times I lived near farmers, and those farmers would come over and, hey, apologize. We've been spraying the fields, and there's some significant smells. Hey, you know what? I appreciate you, but we've got a great thermal envelope, and so we don't smell it. Oh, really? Yeah. We've done our part to ensure that our occupants, our family, can be in a space. My old office at the county was down by the county landfill, right? And so if it wasn't properly if the air barriers weren't properly installed, we would know it, because when you stepped outside, you could smell the landfill, right? But inside, it was beautiful, right? And so again, properly protecting the occupants. That also includes things like weather strips around weather seals around loading docks, vestibules, revolving doors. We'll talk more about vestibules and entrances in a couple weeks when we really bring that up. But again, other things that are required by the code are going to be these mechanical systems. Now, the code, again, the Energy Code reminds us that we need to look for certain types of verification and commissioning associated with certain types of equipment. But from the design perspective, when we see it in action, we know that we're looking for design calcs. We're looking for distribution, equipment efficiency controls, like we talked about earlier. Well, what does that mean to an inspector? Well, to an inspector, that means that I have to understand that there was a calculation, right? The plan review did their part and there was a calculation ran and a particular equipment efficiencies were identified. My job is to be the one in the field making sure that those things are installed as was required, as was specified or approved. Right? If I go out and I see that there are 3 mechanical systems to be installed, and this is their rating, their sizes, their efficiency ratings, I'm going to make sure they're there. Right? I'm not going to say, well, they put in 3 systems, and yeah, they're not. They're the same size. They're just not as efficient. No, this is part of that relationship, right? The plans examiner did their part and made sure that the proper SEER rating was on the equipment. You make sure the proper SEER rating is on the equipment in the field, right? Make sure it's the right size. You don't go out there and say, hey, they're putting in a 1-ton unit, and when I got there, there was a 2-ton unit. Well, is it oversized? To what degree? Is that approved? Do you want to do that in-field plan review? No. And again, we want to make sure that, or maybe it's the opposite, where they're supposed to put in a 2 and they put in a 1, right? That's going to be the problem that we start to address. And so as an inspector, I'm verifying that what was expected is what's installed. And if that means I should be looking at every piece of equipment. You wouldn't shortchange it if it was individual projects. So when you have a project that has 20 different pieces of equipment, you inspect all 20. You don't say, well, I would the way I always treat it, which again, maybe I'm wrong, but the way I would treat it, if that was 20 different projects, I would not sit there and say, I'm only doing 18 projects this week. I'm going to look at all 20. And so I'm going to do the same thing when it comes to my building projects. I'm going to look at each piece of equipment and make sure it's properly installed. I'm not going to guess or assume. Well, and if I am going to guess or do some kind of random sample of designs, then again, I'm going to have that as part of my policy, and I'm going to know what I'm expected to inspect, because expecting what you're going to inspect is the key to a successful inspection process. And that also includes things like controls. So, we understand that controls have been identified, sequences have been evaluated by the plans examiner. So when I go on the site, I need to know what kind of controls are for each individual unit. When I have this entrance space and this has this unit, I'm making sure that we have the proper controls in place and sequences, right? And that also includes the installation and construction of that distribution system, right? We know the code identifies certain insulation values given the location, and so I need to know, is this within the thermal envelope? Is this supposed to be insulated? What are those insulation expectations? And part of that too includes understanding what the building was, right? If my original design, and this happened to me, and I've told you about this, I could not find a picture of it beforehand. So I've called them, I'm going to go out and take a picture here soon. But when this originally was designed, this was one large warehouse. And when we go out to do our inspection, we see steel framing because they're installing 36 different office spaces in there. Wait a minute, that's not the mechanical design. Your mechanical design was based on a large warehouse, a 100,000 square foot warehouse. We're now adding in a series of offices. So we need to recalculate or reassess the mechanical need, right? The mechanical load of that building. Same thing when we start talking about other designs, right? If I'm going in expecting that this is going to be a warehouse or this is going to be an office building, and it turns into, well, it's not just an office building, it's also an office building with vehicle maintenance, a spray paint, and a car wash area, then again, I'm going to evaluate how are these going to effectively meet the load and for ventilation, exhaust, for space conditioning, right? Those are all parts of my inspection as a mechanical inspector, and it also is part of the energy inspection, right? We want to make sure that we are accurately evaluating the system's design. And so if you've told me that this is going to be a certain way, it needs to be reflective of that design. That's my role as an inspector, right? Looking at the ductwork to make sure it's properly installed, properly sealed, making sure that we don't have these types of issues of kinking I think it's the best way I can call it, kinking the ventilation. So again, we have proper flow, proper insulation, proper installation, proper sealing of some of these penetrations when the terminations and those kinds of things, right? We want to make sure these systems work effectively. We understand there's certain level of duct leakage permitted by the code because the code understands that we should be inspecting them. We don't just allow it to be we trust this guy. He's never gone wrong before. We'll go with it, right? We need to have those expectations when we go out in the field. The code also gets into a variety of different types of prescriptive equipment. Again, if we have these types of equipment, then the code would tell us what we need to expect. And as plans examiners doing their job, we should have these details for the inspector in the field. We'll talk more about mechanical systems and get a little deeper into what we're looking for in these when we talk about mechanical inspections later. Mechanical also incorporates the surface water heating, obviously, like we talked about. And so that section, again, addresses controls, efficiencies, and different expectations. Again, knowing that we have mandatory requirements for the load calculation. Are we addressing pools? Is there a pool? Is there a heat trap associated with the design? Are we thinking about what our recirculation pumps look like? Again, are we one of the things that we look for when we do these inspections is the difference between fuel systems, or if we're expecting to see an electric water meter and we show up and there's a natural gas InstaHot. Did we think about that when we sized our equipment? Did we think about that when we thought about all the other components associated with the design? And again, heat trace. Again, do we have proper controls so that we're not constantly running heat trace when there's no use for the system, or the temperature doesn't require the use of these systems? And again, like we said, there's going to be some prescriptive components when it comes to the size of equipment and what are the capacities. And so again, we'll talk about those in more detail later. We don't have time. I got 10 minutes to get through the rest of this. So when we think about electrical components, right, we think about the electrical lighting, the power, the calculations, right? We think about power calculations, we think about controls, we think about the efficacy of the lamps. Some of those are easier than others to do, right? But when we start thinking about how do we verify, the code again reminds us to verify it. And we know that automatic controls were removed from the state's adoption. So we want to make sure we recognize that. But when we start thinking about how did we calculate that power, again, we calculate that power based on a certain type of design, right? The code tells us that we should be looking at either the simplified building method, the building area, or the space by space method. As an inspector, these are design considerations, right? We understand that this is design considerations. As an inspector, I'm making sure that what they designed for is what the building's being used for, right? If they use one of the simplified options and we go out there and it's not the simplified process they thought it would be, right? They put down, we're just doing an office building, right? Well, is that office building this, or is the office building the entire addition, the building, right? What are we looking for? This really wouldn't be a simplified building. This is more of a space by space map calculation, right? And so that means we have to think about those kinds of considerations. We want to make sure that we're seeing in the field what our plans examiner reviewed, right? We think about lighting controls and what those expectations are. Again, we'll have deeper conversations about those. But again, part of that responsibility, that relationship, is that my plans examiner has reviewed the project, determined the locations, and how they match and flow with the different expectations of the system. And so then we're doing that verification in the field, right? Again, if we're looking at a system and we see that the building area is more, was what was identified, and the square footages are off, or the uses are off, then maybe they need to go to a space by space calculation for that alternative compliance. That's again where we are, as the inspectors, the eyes of the plans examiner in the field doing the work. And when we get into the conversation, we'll talk more about how we need to evaluate what's necessarily required lighting controls versus secondary controls, or when we're talking about, do we need to have dimmers versus time switches versus the different components and sequencing. Those are conversations, that relationship where the plans examiners reviewed some of this with the designer. Now we're reviewing it with the installer in the field to make sure that the project is successful. And again, there are going to be other pieces of equipment that will get pulled into it, and that's where we're going to have a role, right? If we're looking at certain types of equipment, we're making sure that they shut down. or maybe they have the different features that we need them to have in order to be energy code compliant. Right? We think about the stand. I think about elevators, right? Um, when I come out, when I'll be out there next week for the U of M conference training series, I guarantee that my brain is at least once going to think about, I wonder if this elevator shut down as I go up to my room, right? Does it de-energize as it's supposed to? When I walk through the airport, I'm looking to see, does the escalator actually slow down, right? I've been in the airport when it does, right? And you can, Denver is one where you can walk through and you can see when there's nobody on it and you're sitting there waiting. There's nothing more. I don't know if you guys are people watchers. I'm a people watcher. And so I'll sit there and I'll just watch the escalator. I look weird, right? I'll admit that. But when I'm watching that escalator, I'm watching it slow when there's nobody on the escalator, when there's no traffic. You can see the sensor that calculates when it comes on. I think at MSP out there in Minneapolis, I think that system, if I remember correctly, as you get ready to exit, it says, please watch, please pay attention as you exit, right? It's got the sensors. And so those same sensors can be used or used sometimes to restrict or augment the flow of those devices. So again, there are some equipment that is part of the system that code identifies having additional expectations. And so, again, that's where we come in as the eyes and ears in the field. So, in really thinking about it as a wrap up, and again, I know if anybody has questions, feel free to reach out, put them in the chat, Q&A, whatever makes sense. But really, as an inspector, what I'm looking for, right, the impact that design has on me as an inspector is I need to know those compliance paths, right? I need to understand what is and where is the building thermal envelope and how is it combined. And we're going to take that in a little bit deeper conversation. The HVAC and water heating systems, again, we'll have a conversation about how we integrate mechanical inspections with energy inspections and performing those in-field verifications. And then with the lighting components, again, whether that's part of the final, that's part of the rough ends, we're looking for those lighting, those occupancies, right, that are consistent. We're looking for those fixtures to be where they're supposed to be. If we start looking at this particular project, we would see that, and I think we'll talk about it again. This is one of my favorite ones to bring up, but we'll bring up some different ones. When we start thinking about how does this system operate, we've got maybe dimmers and controls in office spaces, but occupancy switches that exist in different areas of the building. I have stood in bathrooms, right, as an inspector, hit the override button to turn the light off, and then waited a few seconds, and then waved my arms to see if it would activate, right? Just to make sure that the equipment is working effectively. So again, those are kinds of the things that we're going to be doing. That again, it's not that much. I don't say that much more, but it's a way that we can coordinate our inspections to make sure they're effective. As far as upcoming training, our next webinar next week is going to be on metal buildings. We're going to look at metal buildings in a couple different varieties, looking at it from both a plan and an inspection perspective. And then we'll get back to our normal conversation about design. For those of you that may have questions, make sure you submit them either through the email, through the survey, however you want to get them to us, or bring them to us on the 30th when we have our webinar. We'll have our team together to kind of have bring us your energy code questions, frequently asked, or you can ask them right there, and we can talk about it. And then we'll get back into some other conversations. Again, remember, we got some upcoming in-person training. So our team will be at the U of M next week doing a couple different trainings. So feel free to if you're there and don't attend, make sure you reach out to us, find us, say hi. And I know we'll be at the ICC Region 3 as well. We'll be hosting a special booth there, and we'll also be having our first. I'm gonna let you guys know we're gonna have what's called our first building safety code collaborative. Right, that's gonna be an opportunity. We're gonna host it there. Hopefully, have some refreshments and a little bit of CEUs, but really getting to talk as a larger group about what is code development look like. How do we collaborate in code development, looking towards the future? I hope you all currently participate in the different tags. I know residential yesterday, I think was it mechanicals next week if I remember correctly. Make sure you participate in that. But again, one of those opportunities to maybe for us to talk about what is some of the best practices out there is going to be at that Region 3 training. So if you have any questions, feel free to always reach out to us either by email or through our helpline. And then again, make sure you use those surveys. Give us some ideas on what would be good training. If there's a particular type of design that you see more, if it's not the convenience store, what is it? So we can make sure we get the right buildings in place for you to look and evaluate. And as always, reach out to us if you have any questions. You can reach out to Hope or I, or to our circuit riders that are out there. But I will give you a couple minutes back in your day. I appreciate you joining us. If you have any questions, reach out to me. And other than that, you guys have a great week. I'll hold on for just a little bit in case anybody has any questions. But otherwise, you guys can start to get on out of here.